In this video, we're going to continue with activity 3.1.4, while loop sniff structures. This is actually the second part of the part 2 video. So you will, if you're catching this at this point, so we have already done some steps in part 2, so you'll want to check out the part 2A video. And right now we're looking at part 2B. So right now we've already, just to kind of recap, we built out a code to where we could have variable speed control with the potentiometer to control our motor, and we added a second if else statement to go through and add the right motor in only if the condition is that the potentiometer reads exactly a value of 0, if it's equal to 0. So we're going to build out some more code. We want to kind of take a look at this because up to this point in activity 3.1.3 we ended up we used these wait until statements. So, and we were able to accomplish a lot with those. But now we're going to see when is it best to utilize a wait until statement and when is it best to utilize an if condition, or in this scenario of what kind of effect does it have on our program in terms of our behaviors. So we're going to go ahead and build out these programs and compare how they exactly look in VEX code. So I'm going to go ahead and move to VEX code. I'm still in activity 3.1.2 part 2, so I can go ahead and kind of leave this code alone, and what I'm going to do is go ahead and build out the particular code that we have. We could leave this one and kind of set it aside, and that's probably what I'll do, is just kind of set this off to the side here, so that way it's out of the screen. And we're going to go ahead and start building out by, we're going to make sure that we're going to set the LED off. We're going to grab a forever loop, and we're going to end up putting in the control, we're going to grab a wait until. In the sensing, we're going to go ahead and find our bumper switch condition, so we're going to say wait until the bumper switch is turned on. Then we're going to go ahead, while I'm up here, I'm going to grab both of these LED blocks. We're going to turn one off and turn one on, so the second one gets turned off. And then going back to control, we'll wait for 2 seconds. I'll drop that in between the two purple blocks that we had. I'm going to go ahead and I'm going to duplicate this wait until and go ahead and drop this in there. Now I can go ahead and get rid of these few commands here. I might grab that wait condition out of there because I don't need the LEDs, and I'll kind of leave that to kind of hang out there for a moment. But I'm going to go to operators. I'm going to take out this operator. We're going to say grab the greater than operator, go up to sensing, and what we're going to say is if the potentiometer, we're going to wait until the potentiometer reads greater than 0, and then up in motion we can set this to set our velocity to be the same as the potentiometer, so creating that variable speed. I'll drop that in there. We can spin the left motor going forward. We'll wait for 1 second, and then we will stop the motor. So here's our code that we have. I'm going to go ahead and download, and I'll hit run. So right now it's waiting until the bumper is pressed. We'll watch the LED flash. So there it turns on and turns off after 2 seconds. Then it says it's going to wait for the potentiometer to be greater than 0. So my potentiometer is reading at 0. Once I get past it, once I turn it greater than 0, okay, so there was what we saw was when I pressed the button, the LED turns on. I had to actually turn my potentiometer to past 0. That's why I wasn't responding. and this is all that's happening. So it just goes through and runs for the 1 second and stops. But every time I hit the button, the light has to come on first, which is the way it's ordered here in the forever loop, and then the motor runs. So here is where we can go through and make some changes. So you can see definitely I can't run, for example, I cannot run my motor at the same time as running the LED, or I cannot have it where the motor runs before the LED gets turned on. So now let's go ahead and we're going to build out, and I'm going to go ahead and grab this code and kind of set it here to the side, and we're going to grab two if conditions from our control section. And they're going to both be on the same kind of level, so they're not going to be nested. And what we're going to do is I'm going to grab the condition here, and I'm going to get rid of the wait until block, and I'll go ahead and set this is what we're going to do if the bumper switch is pressed. And then I'm going to go ahead and grab this operator in condition and drop it into the if, and then get rid of the wait until block like I did. And I'm going to drop this set of commands in for the if. So now let's see the effect. Now if I run the program, now my potentiometer is set higher than 0, so if I hit run, my motor's going to automatically kind of turn on. And now if I press my button, my light turns on, but you can see this continues to run. And then so here will be my light once I go through and have that going on. So it's going to check. Now here's the thing, is that it has to kind of, once it runs and stops the motor, you know, once I hit it at a certain time, then the light turns on. Like right now I'm pressing it and it's not turning on, the motor doesn't stop. So that's the thing that's kind of happening. Both of these conditions are kind of competing with each other, and so there's only certain times when I can hit it. But when I hit it in the right time at where it stops in there in its sequence, then I can go ahead and get it to happen. So now if I go ahead and if I turn this down to 0, now when I turn on now I can turn on the light pretty much anytime whenever I want. So because now the condition for the potentiometer is not true, which means it's going to ignore all the code, all these commands, the blue commands for the motor get ignored, and it's only responding to if the bumper switch is pressed. So whereas when I turn the motor on, you know, everything's fine, but again I got competing conditions. So that's why you'll notice here when I press the button, it only does it because I'm getting to the point where it's past the stop motor command. I'm actually kind of picking a time where it's actually found a spot in there to where I can actually interject and get the light to turn on. So that's kind of the effect though. But I have the looping situation going on. The wait until that we were looking at definitely goes through and holds the program and only allows those things to happen in that order. I have to press the switch first, and I have to make sure the potentiometer is turned so that way I can turn on the motor. Whereas these things continue to happen and can happen at different points. You know, you don't necessarily have to have the bumper switch being pressed first in order for it to run the code. So this is kind of the situation that goes with if else and if conditions and everything. So, you know, looking at comparing those two behaviors, there's definitely some times where wait until is very helpful, but depending upon what you want to get out of it, it may not be the best thing because it may keep you from being able to move on and to check other sections of code later on down in your program. Alright, so this part right here is activity 3.1.4 part 2. What I'm going to do is I'm going to get ready for part 3. So I'm going to go ahead and say save as. Even though we've still got part 2 code up there, I'm going to go ahead and name it to part 3. Hit save. And I'm going to go ahead and get rid of all the part 2 code. I had another one over here at the side. And in the next video, we'll get started with part 3 and start looking at if and else conditions within our programming blocks.